Hello everyone, thanks for joining me on another video. Now this is the first bit of content, actual content, that we're going to be looking at in our statistics course. So obviously for a lot of you, this may be your first kind of exposure to the idea of statistics and dealing with data. So we're going to go through this at a quite slow pace, so I can just slowly ease you into some of the terminology of statistics and the different types of plotting that we can do of data. Now, you've heard me say this word plot data or plotting data. What we have to understand is that the mathematical vocabulary is a little bit different to the everyday one we use. So when we say the word plot, we don't mean the plot of a movie or the plot of a novel. We're talking about, in the context of maths, plotting something or to plot something just means to draw on a graph or map. So it's safe to assume that we're going to be working a lot with different types of graphs in this course. Now, what have I drawn here? I have a bunch of numbers written out. And let's say this is the data collected from a class, say a year 7 class in high school. And this is the results of their maths test. And the marks are out of 20. So what I have here is a set of data. Data is just information. And I've collected these test results and I'm going to try to make sense of them and sort of be able to gather information about these test results. So this particular set that I've drawn, we're going to be going back to in future videos. So you'll be seeing this particular set quite a few times across the different videos we see. But this thing, all we need to know now is this is what we call a data set. So any collection of information about literally anything. This can be tests, this can be score tests. Data can be, a number of heights collected from a group of people, the causes of death in a particular country, and it extends so far. I could go all day talking about this, but let's just keep the current data set we're looking at as, let's say, the score on a math test taken from one class. So here we're going to look at our first data plot, the first sort of graphing or visual technique for making sense of this data. And that is what we call a stem and leaf plot. So when we look at data, let me go back up here. This is shocking to look at, right? Maybe not currently, but because it's not too massive. But you can imagine when we get, hundreds of numbers of data. It's just kind of mind-numbing to look at. We're just crunching numbers at this point. We're essentially working as computers. So what humans have done, and you'll see this across all of our different types of plotting data and techniques we'll learn, is that humans aren't computers. And a lot of the time we like to have data organized in a really neat and visual way because it makes it easier for us to make sense of what we're seeing and have it shown in a nice, compact, pretty way, essentially, for lack of a better word. But when we plot this data, we're going to look first at this stem and leaf plot. Now, I'm quickly going to draw a little table here. And I'm going to label these top bits. So one of these is going to be actually, let me draw it in green to go with the sort of concept of stem and leaf. So, oop, sorry about that. Let's go back here. So we have our stem here, and we have our leaf. Now, the best way I like to think of this, because it is a bit of a weird name, but to kind of conceptualize it for you, if I were to draw a leaf here, I know that's not the best drawing of a leaf that you've seen, but it has two components. It has kind of a stem, a little foundation, and the leaf that grows from that. So we're kind of doing the same thing when we look at stem and leaf plots, because the stem and leaf in this context are just descriptors for the different components of our numbers. So we see a stem and a leaf have two components, and our numbers here have one and two components here. So the stem is our foundation. So we're going to look at representing that as the tens column. That's kind of the first number. And the leaf is just going to be the second number in the ones column of our number. So we have tens and ones in each of these numbers. And we'll see that this extends onto bigger numbers, but not so much. So stem and leaf plots work really well for 2 or 3 digit numbers. But now, when we actually try to plot this data, our stem is going to be our tens column, right? So we have numbers that stretch from as low as 2 all the way up to 20. So with our number 2, for example, we like to plot from lowest to highest. So our number 2, what number is it going to have in its tens column? Well, there is no tens component, right? So that's just going to be a 0 there. And we have a few tens here because we have 13, 15, we have 19 here, a bunch more. And we also have 120. So I'm going to put a 2 here as well. So let's actually start to write out the numbers that we have. Now, like I said before, we like to work from lowest to highest. And when we actually locate these bits of data, we're going to write them going from left to right in our leaf column in ascending order. And you'll see that this is a really concise way, and especially when we look later at calculating bits of certain things about our data, so our mean, median, and our mode and range, which I introduced in the previous video, we will see that it's way easier to calculate this stuff when we work in ascending order. So looking at all our components here, well, our lowest number is a 2. So that's going to be our first term. So we read this as 0, 2. So just the number 2. Next, we have 2 3s, which you may be able to see from the data set. So we have 3, 3. Our next number up is a 5. Oh, sorry. No, we have a 4 here. So we have 4. We have a 5 and a 6. 5, 6. And actually, there's 2 9s as well. Oh, and a 7. See, when we're dealing with a lot of data, it's so hard. And that was a prime example right there. You watching me stumbling tells you that, well, all of this thing here, it's hard to look at. We need an alternative for showing this. And you'll see it gets way easier when we have a big toolkit of different data plots that we can use. I'm actually going to mark these off as I go. So I have 2, we have 3, 2 3s, I should say. We have a 4, a 5, and a 6. And now we have a 7, and actually 3 9s. 1, 2, 3. 7 and 9, 9, 9. Now I've just written all of this data there. And it's way easier to read in a table in ascending order rather than just jumbled up numbers, right? So let's go to our next row here. So this is on our 1. So let's read off some of these numbers. Well, the lowest number in our tens column is this 10 right here. So I have my 1, so I'm just going to put a 0 here. So we have 1 and 0. That's our 10. We have two 11s. 1, 2. Oops. Let's leave this all in the same color, shall we? We have two 11s. We have a 12. Oh, sorry. Once again, I've missed a 10. So let's make this into a 10, another 0, and two 1s. And okay, next we have a 12, two 13s, and a 14. So 12, two 13s, and a 14. I hope I haven't missed any. 12, 13, 13, 14. We have two 15s and a 17. So we can go 5, 5, 7. And we have 18, 19, 20. I think that's everything. 19 and 20. Beautiful. So go back here. 18, 19. And now we can move to our last row to show our 20. Now, I mean, some of you may disagree. For some of you, it may be easier to just look at this data. But to me, our stem and leaf plot orders our data really nicely because we can quickly read off all of our numbers and we can see any duplicates a lot easier. So these three 9s, for example, these two 11s, these two 13s. Putting this and ordering it in ascending order is a lot easier to look at. And you'll see some stem and leaf plots maybe in your exercise books that they'll be in the hundreds. So, here you may have 1 0 and then 2 3 3. So it'll be 102, 103, 103, etc. So stem and leaf plots are really useful for highlighting this type of data. And they can also extend a bit further. If we were looking at, for example, scores from two different classes, well, we can organize our stem and leaf plot as one stem and two leaves here. So say I'm just going to do just a couple of bits of data here. Say the score was just out of 10. So we got 0 and 1. And say this class on the right got pretty good scores. So just for time's sake, let's say this was a class of 5 people, right? So we had, let's say 7, 8, 9, and 2 students got 10 out of 10. And this class on the left, for example, had, let's say they got 2, 3, and from our stem, as we said, our things branch out. So our left side will branch out going towards the left. So they got, let's say 2, 3, that's not what I want, 3, 5, and 7. So we can compare data using these stem and leaf plots. If we're dealing with a smaller data set, obviously it's easier because the stem and leaf plot isn't my favorite. It is a little bit limited. That's why I introduced it first. But we can see that, well, when we have either one set of data like this, we were able to show everything in a really clean manner. I mean, it doesn't look clean because my handwriting's shocking, but if you were to draw this out nicely, it would look really good. And we can also see that, well, if we have two different things, so say we're comparing two different classes or two different age groups, we can show two sets of data simultaneously at the same time. So our one here, well, we can compare this class, whose marks were 7, 8, 9, and 2 tens, with this class, whose marks were 2, 3, 3, 5, and 7. So stem and leaf plots are good in that regard because we can compare different data sets, or we can even just represent one data set in a bit more of a clean way. And we'll see in future videos there are even nicer ways to show this when we start talking about frequency and different types of frequency plots. But we'll get to that all in good time. But for today, that is the stem and leaf plot, which we can use to work through various data sets like the one we've shown here. I'll see you guys next time.